So if you learn this Markovnikov rule, most of your board exam question can be. Hello everyone. So today we are going to discuss regarding the preparation of alkyl halide from alkene. And as you are aware that we are discussing this alkyl halide and aryl halide series, we have discussed regarding various preparation method in the previous lecture also. And today we are going to continue that, and we will discuss regarding how we can prepare these alkyl halide from alkene. And the same reaction is being already studied in class 11th when we were studying the properties of alkene. So alkene we are very familiar. This is our alkene. When a HX is being reacted with this alkene, we get this type of product. C single bond C, one side H and other side X. So this is a bond. This bond is bond breakdown, and one side we are getting this X being attached, and another side we are getting hydrogen being attached. So the question arises at this is a symmetrical alkene. This is a symmetrical alkene. So here the question is not that much complicated that where to attach this hydrogen and X, because both are having the same type of moieties. But when we are having unsymmetrical alkene like this, and this situation, the problem arises that we have to add these two moieties, hydrogen and X. So where to add the hydrogen, and at which side we need to add the halogen. So the two possible reactions of product will be like this: hydrogen over here halogen. Another possibility will be at this side halogen and this side hydrogen. So you can see there are two possibilities: hydrogen at this side and hydrogen at this side. Hydrogen where more number of hydrogen are there, and hydrogen where less number of hydrogen are there. To solve this query, a scientist named Markovnikov gave a very nice rule that is being known as Markovnikov rules. It tells that if we are adding a such polar molecule which is having two polar or induced polar molecule which is having two parts, one is a negative adenum and another is a positive adenum. So what we are going to do, negative part of adenum will join to the less number of hydrogen. So if you learn this Markovnikov rule, most of your board exam question can be solved out. You can very easily solve on the basis of this rule. But if you want to go into some JEE advanced questions and some good question of NEET and JEE, then you need to get into the mechanism of this. Firstly, we will solve the problem on the basis of this Markovnikov. Then we will get into the detail of the mechanism of this whole reaction. So in the back over here, you can see that this is the positive part and this is the negative part. And the Markovnikov rule tells us that the negative part of adenum, that is X negative in this case, will be added to the part of the alkene, that carbon of alkene which is having less number of hydrogen, which means this will be our product. This will be our product, not this. Clear or not this thing? We will understand this concept with some more examples. like this. If we are adding this H and Cl, this is partially positive, it is partially negative. The Markovnikov rule tells that this negative part will add to this hydrogen. So we will get a product CH3, single bond CH2, single bond CH and X at this side, and CH2, single bond. X is Cl in this case, so we have to write down the Cl. Cl and CH2 will be added up with this, like this. So this is the major product. Main product of this reaction will be this one. Or you can have any HCl, HBr, HI. So we are going to get this type of rule. That is, most of our question will be solved on this Markovnikov rule. The thing which we are going to discuss about over here is now the mechanism of this reaction. If you see the mechanism of this reaction, CH3, single bond CH, double bond CH2 plus HX. So what you are expecting? Partially positive charge and partially negative charge. So what is going to happen? This is alkene. It is having a lot of electron in itself. So what it will do? It will attack on this. So there are two possibilities to attack on this HX. So what do you expect? It is already having some electron within itself. So it will attack at H positive part of this reagent. So it will have a possibility like this: CH3, single bond CH, single bond CH2, H. And this minus X will leave out over here. Clear or not this thing? So we are going to have a positive charge at this center. So if the attack is not at this side, if the attack takes place like this, and we are getting a product, the attack from this carbon, then we will see CH3, CH attack at hydrogen and CH2 remain over here and a partial positive charge, complete positive charge over there. So now there are two possibilities. One is this possibility, another is this possibility. Two possibilities we can clearly visualize in this question. Two possibilities are there. So in this two possibility, what we are going to do, that it is a carbocation, and we have already studied the carbocation stability, 3 degree more stable than 2 degree more stable than 1 degree. If you compare these two, this is a 2 degree carbocation because it is attached with two carbons. And regarding this carbon, it is a 1 degree carbocation only attached with one carbon. So we can very easily see that 2 degrees more stable carbocation, which means the reaction is going to proceed through this pathway, not through this pathway. So what we are going to get over here in the next step, this X negative will attack at this CH3, CH positive, single bond CH3, and the product which we are going to get from here will be CH3, CH, and X will attach at this side and CH2, single bond H. This will be the major product. And now you can observe that from here to here, if you are directly coming to this point, you can say you are following the Markovnikov rule. Adenine, negative part of adenine is adding to that hydrogen, that carbon of alkene, which is having lesser number of hydrogen. So it is quietly, most of the questions are going to be solved out with the help of this Markovnikov rule. So this is the whole mechanism. Now we understand this mechanism is proceeding electrophilic addition. Electrophilic addition because it is acting as an electrophile. Addition is taking place. It is an electrophilic addition reaction taking place over here. So now we will take one more example. We are going to discuss one more example to understand this carbocation stability and what are the other possibilities which can be taken over there with this carbocation. This is our reagent, sorry, this is our substrate. When it reacts with HX, what is going to happen? Firstly, I will tell you why the mechanism, then we will see is Markovnikov rule can be applied on this question or not. Firstly, I will follow through with the mechanism, then we will proceed on to the Markovnikov rule. Is Markovnikov rule applicable or not? So over here, just easily you can see partial positive charge and partial negative charge. So what will happen over here? We will see this will attack at this side. The possibility over here is CH, CS3, single bond CS3, single bond CH, single bond CS2. So now one possibility is that this carbon hydrogen attach at this site and we get a carbocation, 1 degree carbocation. Another possibility, what will be the other possibility? Another possibility will be like this, CS3, single bond CS3, over here CH, positive charge, single bond, CH2, single bond H. The H attached at this side, so over here we are getting a 2 degree carbocation. So we have already seen in the previous slide also that 2 degree carbocation is quite more stable than 1 degree carbocation. So we can say the reaction is going to proceed through this. This will be proceeding, the reaction will be proceeding through this, not through this. 1 degree less stable carbocation. Less stable carbocation. So now if you see over here, one more interesting rearrangement is going to take place over here. If you have studied the carbocation with a full devotion, then I have told you that carbocation have H negative, CS3 negative and pH negative type of shift. Sometimes we can see that this type of shift take place to get a more stable carbocation. If you are getting a more stable carbocation with the transfer of any of these, then it is quite more probable that you are going to get such type of hydride, methyl or phenyl shift. So here is a possibility. If you see over here this hydrogen, if you see this hydrogen shift as in the form of hydride and we will see a product like this. This is our carbon. A positive charge will be generated because from here we have taken a hydrogen or you can say hydride and this became H, CH3. So now you can compare both these two structures. Here it is a 3 degree carbocation and that is a 2 degree carbocation, and we know that 2 degree carbocation is less stable than 3 degree carbocation. So this hydride shift is giving us a more stable carbocation, and now the reaction will proceed. This Br negative which was left out will attack over here and we will get a product like this. Okay, sorry, we have made some mistake I think over there. Yes or no? CS3, CH, single bond C, this, and after that one CH and CS3. Over here one positive charge, over here CS2. Yes. This will be like CS2 and CS3. This is the major product we are going to get. CS3, CS3, and at that time we are getting X and this CS2 and CS3. This will be our major product in this question. 3 to 5 carbon, 3 to 5 carbon. So this is the major product. If you follow the Markovnikov rule, you are going to attack X at this center. But this is not proceeding because that's why we need to know the mechanism of the reaction. how the reaction is going to proceed through. So I have shown you the mechanism also and the short trick also. Generally, the Markovnikov rule is being applied in a board exam, but when you are having a higher level exam, JEE Advanced, a good question of JEE Advanced, you are going to, in your mind, this mechanism is going to be running. Some other possibility you need to know. So in today's lecture, we have seen regarding this alkene, how the symmetrical alkene reacts with, how unsymmetrical, what is the rule, Markovnikov rule, and for unsymmetrical alkene, what are the products we are going to get over here. And regarding the whole mechanism, the formation of this carbocation, we have seen over here the carbocation formation, and we have seen the halide shift. So in a very small lecture, we have comprised all these various effects. And in the next lecture, we are going to discuss another way or how we can attach this bromine or alkyl HX group, where we will adding the Br negative at that carbon where the more number of hydrogen are there, and that will be a anti-Markovnikov rule. Anti-Markovnikov rule or Kharash rule, that we are going to study in the next lecture or next slide. And after that, we are going to discuss regarding the various other reactions of alkene, SOCl2 and the alcohols, how we can prepare from all these alkyl halide. That we are going to discuss in the upcoming lecture. Thank you for being with us. Thank you. Have a nice day.